In this explainer video, we'll explore how to expand differences of cubes. There are two approaches for this. First is by using the difference of two cubes formula, and second is by using basic polynomial multiplication, which we'll do for checking purposes. The goal of this video is to make you familiar with the pattern by expanding a few examples. So, let's do this. We'll start with something simple and easy. The first thing you need to do is to check if the expression satisfies the difference of two cubes formula. Look for the probable values of a and b. Then, compute a squared, ab, and b squared so you could compare it to the trinomial part of the polynomial. In this case, a is equal to y, and b is equal to 5. Using these values, a squared is equal to y squared, ab is equal to 5y, and b squared is equal to 25. Comparing these computed values to the trinomial portion of the polynomial, you can observe that the expression follows the difference of cubes formula. Now, compute for a cubed minus b cubed by substituting y and 5. The final answer is y cubed minus 125. Check it using polynomial multiplication, and you'll see that the final answer is the same. Amazing, right? But of course, some of you might think,
the amount of effort kinda looks similar though. I don't really see the advantage of using the difference of cubes formula over basic polynomial multiplication.
To be fair, that is indeed true, because this is a very simple and straightforward application. So, let's try a more difficult example. This example contains more complex looking terms, and if you're not careful with the computations, then there is a huge risk of getting the wrong answer. Let's check if it satisfies the difference of two cubes formula. First, assume that a is equal to 2m squared, and b is equal to 3n. Using these values for computation, a squared is equal to 4m raised to 4, ab is equal to 6m squared n, and b squared is equal to 9n squared. Alright! The expression follows the difference of two cubes formula. Now, compute for a cubed minus b cubed by substituting 2m squared and 3n. The final answer is 8m raised to 6 minus 27n cubed. Check it using polynomial multiplication. Observe that, even though the answer is the same, the multiplication process seems to be a lot longer than the previous example. This is because the terms are now more complex, which means that careless students are more prone to errors using this method. Pretty cool that you can use a shortcut, right? So, for the last example, we'll try something a little bit tricky. Assume that a is equal to 2x squared, and b is equal to 4. Using these values for computation, a squared is equal to 4x raised to 4, ab is equal to 8x squared, and b squared is equal to 16. But it's strange though. A squared is not equal to 3x raised to 4, ab is not equal to 6x squared, and b squared is not equal to 12. Does this mean that the difference of two cubes formula cannot be applied in this example? Actually, the formula is applicable, but the wrong values were used for a and b. Let's try it again. But first, let's factor out 2 from the binomial, and factor out 3 from the trinomial. Now, assume that a is equal to x squared, and b is equal to 2. Using these values for computation, a squared is equal to x raised to 4, ab is equal to 2x squared, and b squared is equal to 4. And now, The expression follows the difference of two cubes formula. Cool trick, right? Compute for the final answer by substituting x squared and 2 for a and b. The final answer is 6x raised to 6 minus 48. Check it using polynomial multiplication, and you'll see that the final answer is the same. If this helped you, then like this video and subscribe to teach me animated math. If you need more challenging problems, then view our solve-along videos about expanding or simplifying polynomials. Click any of these links to help you on your math journey. Feel free to leave a comment if you have questions or if you want to request a solve-along video, okay? So, I'll see you in the next video!